Okay. And we'll go to moderator. We'll go to web campus. Oh, I'm not. So. Oh, that's the wrong one. I need to go there. And I need a new one. Nope. Compressed. What are you talking about? I gotta close this? Good morning, everybody. Welcome, welcome. Got a minute here, so we can do a show and tell with Miss Loaf. We'll give people a few seconds here. And Loaf will get out of here because she doesn't like me talking while she's trying to nap. Yep. Does anyone have any questions right now in regards to maybe the test. For your assignment 4 grades, I'll talk about that when class starts, which is in a few seconds or so. So just give me a moment for that. But if you do have any questions about the test, you can ask them now if you'd like. I did post all of the answers very inefficiently. I guess I'll show you where those are. All of the questions, I like put an answer in it, but I did it after you guys submitted the test. And I don't think that it was going to show you the answers after you completed it, at least the ones that I entered. So I'm not sure if that worked or not. Maybe it did, but you can just come here and see all of these goofy screenshots that I made. So if you're wondering what the answer to question 20 was, I mean, you could just click on this and it says describe what a pointer is, and then I've got the answer here. So pretty much everything you should be able to check. Just by looking at the results of the test, there was nothing out of left field, pretty sure. There was one minor error. It's probably question 3. Yeah, question 3 right here. I already made a comment about this. And you can't probably really read this, but this is where you have to match between kind of the override and the overload stuff. So I gave you like a kind of a definition, and then you have to give it a name. And then this last one here says the global environment contains 2 functions with the same name, type, and parameters. And I said that's a syntax error. It's not necessarily a syntax error. It is an error. And the error is actually a redefinition. You're not allowed to have 2 definitions for one function in the same scope. So if you put syntax error or redefinition, you would have got points for that. Even though Web Campus tells you that it's wrong, you should still see the right amount of points allocated for that. So that was really the only error. And then there was one multiple choice question about inheritance that I saw that may have gotten a few people. But then other than that, it should have been good. Today we're going to start a new topic. Today I also will assign a new assignment. So please hang out for that assignment description. Yeah, most everyone got that. This one. This is what I'm talking about. And the only thing that maybe would have... I mean, we did discuss it a little bit, but it says down at the bottom, in a single inheritance, a base class can be the base class for only one derived class. Now, that's false. And we'll talk about that today. We did discuss what a multiple inheritance is, and that is when a single derived class is inheriting from 2 base classes. And so that was our example with the last names. You remember I did Petrowski and Lopez. And so, in fact, in a single inheritance, I can even just pull up something from the assignment here. Probably this one. So in this image, though it does maybe look like a multiple inheritance, this is in fact single inheritance because player is only inheriting from entity. And weapon is only inheriting from entity. And drag and dagger is only inheriting from weapon. So notice here that it's just a single relationship. And so, just so you know, just as a reminder, this is considered a single inheritance. So now we'll move on. Like I said, you can always message me if you'd like. Looking at the syllabus, just to show you where we are. I have not been keeping up with this. But we are here on virtual functions and abstract classes. I need to move this after the midterm, obviously, because we already took the midterm. Okay, so don't get scared. Midterm exam 1 has already been completed. And now we're kind of in week 6, technically. I'll have to switch this around. And then last thing, I said I'd have your assignment 4s graded, and I do not have them graded. So I'm very sorry for that. It's my goal to give you back your assignments within a week of you completing them. Right now, I think we're sitting at 9 days or so. I will be starting on those today, and I'll try to get them done by tomorrow. I am a busy man myself, and I don't have any TAs, so that's my crappy excuse, but I promise I'll get them done. So thank you for being patient with me on that. So after all of that is said and done, if nobody's got any questions, we'll start talking about our new stuff for the day. And to do that, I'm going to take you back to an assignment that we already did. And I'm warning you, for anyone who is either excited about this or not, assignment 5 is going to be based off of player classes again. It's really just one of the best ways that we can really explain how inheritance and virtual functions work. So this is why I do this. I don't mean to be overloading on the game examples or anything for those of you who hate video games, but this will probably be our last video game assignment. So, given that, I would like us to think back to assignment 3, if you haven't forgotten it yet. And I want you to remember what we did there. And what you were responsible for coding was the parts of the player class, and you were also responsible for coding parts of the entire mage, warrior, and ranger classes. So you should all remember that, I think. And if you remember that assignment, the mage, warrior, and rangers were all inheriting from the player class. And so I'm going to ask you guys a question here. Let me pull up a file. And then I'm going to show you exactly why virtual functions help us, and then we'll kind of define that. And then we'll get started here. So this will be just our first one. I don't know. I'll call it a.cpp. So, like I said, I'm asking you to remember this. So the syntax here, it's going to be mad at me because it doesn't know what a player is, right? I would have had to include it, but just assume that I've imported this header file and we have this thing called player. And so if I said player P1 is equal to, say, a ranger, and let's say that I say player P2 is equal to a warrior. And then what did we call, right? What was the, well, we can go look in the game.cpp, whatever that function name was. It was this deal damage function, right? So what we would do is we would say P1 is dealing damage to P2, right? So say we have this deal damage function, and we would pass P2 into this function. Now you recall that the ranger, I'm just kind of putting this in the comments, damage function, and the player deal damage function were different, right? Because in the player deal damage function, it was just kind of bare bones. You actually didn't have to code this one. I coded it for you. But you coded the ranger deal damage function, right? And in this function, rangers deal super effective damage towards, I think, mage, and they deal not very effective damage against warrior. So given this code, can anyone tell me which of these functions I'm calling right now? So just understand that I said this is a player object and I gave it a ranger constructor. This is completely legal, just as this is legal. And then I called deal damage from the object. Is it going to call the player one or is it going to call the ranger one? Or what do you think? So we got one vote for ranger. Does anyone else want to vote before I give it away? Okay, so that's a 3, 2, 1, and going gone. What happens here actually is the player deal damage function is called. Now I would really like it to call the ranger deal damage function. Why? Because I said this player is a ranger player, right? But in order for this to work, I have to say this. I have to say that this is a ranger from this. Remember that this is a static variable, right? This is a static variable. And if I want to call the ranger deal damage function, I have to specify this as a ranger. And that's really annoying. And I'll show you in the game.cpp file, I have, and the team.cpp file, and team.h, I have all of this ridiculous code in place. So look at this, for example. A team has a vector for rangers, a vector for warriors, and a vector for mages. This program would be so much simpler if I could just have a vector for player and call that the team. And if this player vector knew which of them were mages, warriors, or rangers, then we'd be good, right? And we wouldn't have to specify them. And look, I even put a comment here that says, I wish we could use just one big array for player types. And then I said, we do not know virtuals yet, so we need 3 arrays. So I even offered some foreshadowing in this assignment. So we've got 3, look at those. I've got 3 vectors here. I had to get 3 getters, right? So I can get a ranger, I have to get a mage, and I have to get a warrior. And then if we come in the game.cpp file, look at this big disgusting, I even quote myself here, big disgusting. This is a big disgusting if-else statement in which I am checking if it's an R and an R, and if so, I'm going to call get ranger, and I'm going to call deal damage from the ranger. Or if it's a mage, I'll call deal damage from the mage, or if it's a warrior, I'll call deal damage from the warrior. This entire if-else statement could be replaced with one line of code with the use of virtuals. So I'm going to begin typing in some notes here and explaining what's going on. And can anyone confirm for me, is next week spring break? I kind of get lost. Okay, thank you. I had an idea. Let me know what your thoughts on this. I was thinking, I think they're going to be doing server maintenance over spring break. I'll have to double check on that, but I was thinking we could have an extra credit opportunity over the spring break. And what the extra credit opportunity would be is for you to take the assignment 3 program, a completed version that I send you, with some added comments, and you would convert it to use virtuals. So I think that would be a fun extra credit opportunity. It will not be the actual virtuals assignment, which I said will be pretty small, and I'll assign at the end of today. But if you think you'd be interested in that, please let me know. So now we're going to get started with our notes, as I said. I think I'd make it quite a few points, not just like a 10-pointer. It would be a significant amount of points. Maybe not 100, but somewhere in the 40-50 range, because it would take some time. it wouldn't take a whole lot of time, but yeah, you guys like it? Okay, so I'll do it. I'll see if I can set that up. I think it would be very helpful for you guys to figure out how virtuals really function and how they work. And so let me check my actual notes here. Okay, so virtuals and abstract classes. So when we talk about virtuals, virtual functions, that is, there is always a class involved. There's always a class involved. And in fact, this is something I would remember. If we are dealing with virtuals, there will be a pointer to a base class that holds an object of a derived class. Does that make sense? And I'll give a small example here. So for example, from assignment 3, I would say we'd have a player, and it would be a pointer. And I would say something like this. Just kind of like I showed you in this main. Right here, right where I say this. Except, like I said, this doesn't work, and it's because we're using static variables. But if I made this a pointer, and I said new warrior, now we have the opportunity to work with virtuals. Okay? Notice that this is the base class, and this is the derived class. This is just a small example of that. So remember that for a test. Okay, when I ask that question, if a class contains a virtual function, what are we likely dealing with? Something like that. And the answer is, we are going to have a pointer to a base class that holds an object of a derived class. And so this topic is actually not very difficult. A few things we have to talk about is just a regular virtual function. We have to talk about a pure virtual function. We have to talk about what an abstract class is. And we have to talk about pure virtual destructors. Whoa, I did not spell that right. And let's see here. We can also have just a regular virtual destructor as well. So that looks like a lot, but it's not, I promise. So let's begin with just a regular virtual function. And then we'll kind of code as we go here. So a virtual function is a member function in a class that has the keyword virtual in front of the prototype or definition. But let's just say prototype, because if we're going to define it outside of the class, we don't need to carry the virtual over. So let's get started with that. I'm going to get rid of this. And I did do an example program before we got started today, so I just want to have that available so I can avoid as many mistakes as possible. All right, what would I like to do here? So today we're going to deal with shapes. We're going back to kindergarten. So let's pretend that we've got a class shape. And I will change this up a little bit later. But that's just a mental note for me. So let's assume our shape has a shape name, like circle or square. Let's also assume that we might have some integer for number of sides. Okay, now a circle supposedly has an infinite number of sides, or it has no sides. I don't know how you look at it, but we will handle that. This is more of a coding example and less of a geometry problem. And so our shape's probably going to have a default constructor, right? Let's go ahead and initialize these things. Since this is just a shape, and I don't know what shape it is, I'm going to initialize this to be like a no name. And let's go ahead and initialize our num sides to be something like 0. Okay, I'll put the body there because why not? Let's go ahead and do a parameter constructor as always. You guys should know this by heart now, right? But I did say at the beginning of the semester that I will be doing this for you all of the time. So if you're still having confusion on how to do constructors, here I am doing them again. So we'll initialize those guys. Just give it a body. Because I initialized these right, we don't have to put anything here in the body. Unless I had a static variable for the shape count or something, but we're not doing that. I am going to have this destructor here just because I'm going to show you later on the order of execution. So we're just going to say goodbye to the shape here. And then now we're going to finally do our virtual stuff. So let's say I have a function called void print shape details. All right, so this is what we'll call it. It'll be a constant function because nothing in here is going to affect these variables. In here for now, we're going to assume that this function will be overridden. By some derived classes, right? This is going to be our base class. And let's just say that this one will say unknown shape has unknown sides. So I think you should all agree with that. That just a regular shape here is unknown to us. I mean, at the moment, we don't know what shape it is. We don't know how many sides it is. Now, if I want this to be a virtual, all I have to do is type virtual up front. I have to spell it correctly as well, and it'll turn blue. And that's our syntax. So let's go back to our notes here. These functions are meant to be overridden in the derived class. In a base class, I'll say. Base class. Whoops. So we'll just start with that, and let's go ahead and have some examples for now. So now I'm going to derive two other classes. Let's do a circle, and let's do a square. So we're going to have, say, first off, just a square. And it can inherit from this class, right? This is our base class, and we're going to be inheriting from shape. A square is a shape. A shape is not a square. So let's go ahead and inherit publicly, let's say. Public shape. And what does our square have to have? Probably not very much stuff. It already has this stuff. Probably will need just a constructor. I'll do a destructor as well, and we're going to override this virtual function. And then we're going to do some compiling. So in our public, let's go ahead and have a square constructor. and let's say we want to specify a constructor in this class, right? Probably not this one, right? We know that a square has a name, and we know that it has 4 sides. So let's go ahead and call this parameter constructor here. And so let's go ahead and call shape constructor, and let's pass it square, and let's pass it 4. Good enough, right? Nothing else here we really need to do. Let's go ahead and make a destructor just so I can show you the order of operations. And so here we're actually going to say goodbye square. Good night moon. Good night square. And then lastly, we're going to override this function here. All right, so I'm actually going to copy it. And let's say this. Let's put this in our notes. The overridden function in the derived class does not have to be virtual. Okay? It can be, though, if further classes will be derived from the derived class. So hopefully that makes sense. So there's no requirement that the overridden function has to be virtual. What do I mean by that? I mean that all I have to do is come up here and copy everything except for the virtual part. Just paste it, right? So there's no virtual here. That's what I'm saying. It's not required there. It only is required in the base class. And in the shape details here, notice I'm not referencing these. This is just as an example, right? I would probably do something like shape name is equal to shape name in my cout statement, and number of sides is equal to num sides in my cout statement. But I'm not doing that because it takes time, and we always don't have some time. So we're going to say here, square has 4 sides. Hope you're okay with that. And then we're going to do our circle. Circle is going to be really easy. And I'm going to use some of my knowledge here. So I think I have to do this, 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 this. And I can just type circle. Wow, that was nice. For those of you who don't know what I did, I held Alt and I clicked on all of the things that I wanted to replace. You can also do a Control F, find and replace as well. And let's say a circle has -1 sides because circles, like I said, can't really count. Has 1 side, right? Is that fair? Circle has I don't know sides. All right, so here we go. We've got our inheritance, right? It is a single inheritance where we've got the shape up here. So we've got our shape up here. It's a little small for me. That's much better. And then we've got the square, and we've got the circle. And in here, we've got our small virtual function. I'm just going to say virtual. So now let's get in main and show you what's going on here. So what I said before is, let's say I have a shape 1. And I say, hey, I want this to be a square. And then I come down here to S1 and I type, boom, print shape details. Now, regardless that this is virtual, there's no pointer. There's no pointer here. I said we need a pointer. And so when we take this to Bobby or Sally, we should see, can anyone tell me which one will be called? I'm checking in with you guys. Is the shape print shape details going to be called, or is the square print shape details going to be called? can leave that there, I think. I don't need that. What did I say this as? This is A. Okay. The shape, exactly. So we should see this, that print statement, right? Unknown shape has unknown sides. And that's because we're using a static variable. So hopefully it'll load up here. Hopefully I don't get caught off guard. I guess I have to change my directory. And look at that. I know why that's happening. That's because we called a constructor here, and then we made a copy of it. And then after this statement executed, the destructor for whatever this was called. But aside from that, notice here we say unknown shape has unknown sides. Now, alternatively, let's make this a pointer now. Now this is a problem, right? Because S1 is a pointer, so we have to change this to an arrow. Alternatively, I can dereference it and then call the dot operator on it. And I don't want any memory leaks here, so I'm going to delete my S1 down here. And then if I want to avoid any dangling pointers, though it doesn't matter, let's set it to null because we're being safe. So now that this is a virtual function, we should see square has 4 sides. So let's do that. And then I'll take out the virtual and I'll show you which function gets called again. Whoops. Look. Square has 4 sides. Now this is great. Look at this. Notice here it says square has 4 sides, right? And so we expected that because this is a virtual function and we overrode it. I guess that's the word. We did a function override in the square. And so when we went into this pointer and we called print shape details, the runtime says, hey, is this function a virtual? It says, yes, it is. So it starts going down the chain as far as it can until it finds the end. In the case, the end is either the last class in the inheritance chain. So in this case, the last class in the inheritance chain is either a square or it's a circle, or until it doesn't find a virtual anymore. So in this case, it went from square to, or it went from shape to square, and it said, hey, there's no virtual here anymore. I'm going to stop, and I'm going to call this function. Now notice, in our execution here, which destructor here is called, and does it look like we missed one? I mean, it's kind of an easy question. We did miss a constructor, or we missed a destructor, right? And notice down here, so we can have a virtual destructor. What happened here? So notice here that this shape is not virtual. It's not virtual. And so when I call delete S1, which is a shape pointer, it said, looked at the destructor, it said, hey, this isn't virtual, so it called it. But guess what? All I have to do here is add a virtual in front of the destructor. And now it's going to go down the chain until it either reaches the end, of the inheritance chain, or until it doesn't see a virtual anymore. So it will go from shape to square, it will notice that there's not a virtual in front of square, at least this destructor. So it'll say, I'll stop, and I'll call this one. But then remember that a square is a shape, so then we should see this destructor gets called as well. Even though it's virtual, it still has a body, right? And so we should see goodbye square, goodbye shape. Are you guys following so far? Are there any questions about what's going on here? I do think this subject is, not as mind-numbing as maybe the pointers. So Red Rose asks, the reason to use virtual is to change which functions are called in inheritance. Yeah, I would say that's kind of a vague way to put it. And I do need to define something for you guys real quick. So we'll go do that. But notice here that I added the virtual in the square destructor. Or no, I added the virtual in the shape destructor. And so then it went down the chain and it said, wait, this is a square. So it called the square destructor first, and then it went back up and called the shape destructor. So what virtuals do, and I'll clean these notes up, I always do. How do virtuals help us? They help us obtain runtime polymorphism. Now, I'm going to give you a few links. These are some great links that you can reference, okay? So this will be for virtual functions and destructors. Just put them here in the notes, which is just what we covered, right? We just did a virtual function, and we just did a virtual destructor. Now, runtime polymorphism. Let me give you the Google definition of polymorphism before I say something bad. Because it's kind of hard for me to explain. And so maybe we can kind of look at it. And this is pretty good. We're going to kind of have to put things together here. But the key word here is in several different forms, right? And so in inheritance, the shape can take many different forms. And so the shape can take a square form, it can take a circle form, and if we don't have the polymorphism, that's kind of when we're doing this, this object will not be able to take its different forms. If I say that this is a shape, it's always going to be a shape. Until I introduce virtuals, then I have the option to say, hey, this can be a square, this can be a circle, this can be anything. But to make sure we call the right functions, we're going to specify that this is a virtual class, or the functions within this class are virtuals. So let me see if I can put that in our notes. And when we talk about polymorphism, you probably think of function overloading. That's a form of polymorphism. Why is that? Because the functions have the same name, right? But they take different forms. We also have function overrides. Right? The functions have the same name and parameter, but they're kind of different forms. They're in different scopes. Another example of that is virtuals. And also operator overloading, which is coming up next week. And to specify this is going to be runtime polymorphism. This is good to know. But these are going to be compile time polymorphism. I'll kind of tab these out. Did that kind of answer your question, Red Rose? I'm not looking at the chat right now, so I don't know if you responded, but That's kind of why we use virtuals. Is so in computer science, we try to be as general as possible. And when we say being general, we mean that we want to have the simplest solution possible. And so when we think back to that assignment 3, when I said a team has a warrior, a ranger, and a mage, I had to implement a solution that is not as general. I have to specify these 3 separate classes. I have to do all these if statements, but because they're all players, if I can introduce this idea of runtime polymorphism in virtuals, our life becomes so much easier because we can just use a pointer, and then the runtime will determine if we're talking about a warrior or a mage or a ranger, or in this case, a square. So we can do a few other examples here before we move on. So if this is a circle, we can print just a reminder, right? This is the arrow operator. If you haven't known yet, these are the same. And then we can do S3, which let's just say is new shape. And I can call it print shape details. Definitely. Well, so here's the main thing. When is dynamic memory allocated? This is a dynamic variable. And so dynamic variables are allocated during runtime. And so if that helps you kind of remember this, notice for runtime polymorphism, we have to do things during runtime. We're allocating memory during runtime, and then it's up to the runtime to determine which square, circle, or shape we're talking about. All right, so I'm going to print these. Now, this one's virtual, right? This function is virtual. But because I said this is a shape, it says, can you, yeah, let's do that. He asks, can you change what that shape is later on during runtime? Yeah, so I'm going to create, let me do this instead. Are you okay with this? And if you're okay with me doing this, can you tell me what I just did as well? What is bad about what I just did? But yeah, we can change the shape, and you'll see that it works. Right. Yeah, so here I did this. This is bad, but I'll just run the compiler real quick. That's a memory leak. Yeah, that's exactly what that is, right? So it would have been better if I deleted S1 first. But you're okay that I do this, right? I'm still going to change the shape of this pointer, right? I'm going to change it from a shape or a square to a circle. And you'll see that it works. Please comment out. Thank you. That's not what I want. I didn't compile it. Sorry, everybody. Okay. I don't need this one open. Yeah, ask the questions, guys. If you have to, let's get this figured out. So notice here we say square has 4 sides, right? So we called it. We called this was allocated to be a square, and it printed it. And then I called delete, right? And so we should see goodbye square, goodbye shape. And then it called the circle. So notice that it changed, right? And we notice here that it changed because we allocated a new circle into this. If you guys could just give me 1 second. I know this is unprofessional, but I'm hearing some weird noises in my house, so I'll just be right back. Just want to make sure that there's not a murderer in my house. I'm sorry about that. And then lastly, I can delete this S1. And then I can assign the same value. But in this case, I'll say this is just a shape. And then when I take this on to Bobby, I can compile this. And everything will be good to go. So notice here, during runtime, we have the ability to allocate different... Now, this here's what I'll say. This kind of messed some people up on the test. Especially when we talked about static variables. So if I say something like this. And I asked you explain what this is. And many of you said, this is the same for all classes. Meaning there's only one object for all classes. Now I would have marked you points off that. Because that's not true. What the correct statement is, there's only one of these for all objects of a class. The moment I come up here and I say class Bob... This shape count is not shared by all classes because class Bob doesn't have it. You know what I mean? So just remember when you want to talk about like multiple, the term we use is objects, right? So these are objects of a class. And so what Virtuals gives us the opportunity to do is to assign multiple objects from different classes, as long as they're related in some inheritance hierarchy, into a single pointer. And then during the runtime, we can determine which one we're talking about. So let's get back to our notes and continue on. I should probably put some syntax in here, because we all love a little bit of syntax. So this is going to be something virtual, the type, the function name, whatever params you decide to give it, and then a body, right, with some code in there. And then a virtual destructor. This is the same as a virtual function. But we need this because we need to sometimes specify which destructor should be called first. This is very important to avoid things like memory leaks. So let's get some syntax. This is going to be virtual class name, right? And then some code. So now we're going to get into pure virtual and pure, just pure virtual stuff. So a pure virtual function has no body. Other than that, operates similar to a virtual function. So let's do that. So we're just going to save this code for now. But I am going to copy it over into a new editor. And we're going to add to it. And this will kind of help us with assignment 5 as well. So I'm going to add another class to this. I'm going to add another class to this code here. So I'm going to make a class entity. This same class is in your assignment 5. And we're just going to say an entity is like anything. If it's an entity, it has existence, you know? So this is like the base class for all this is base class for all classes. And let's see what I put in this entity class. Maybe I'll save this for the pure... Well, we're doing pure virtuals. I don't like it. We'll come back. I don't like it. Instead, let's make this a pure virtual function instead. So what did I say? I said a pure virtual function has no body. So what is the syntax for that? How do we specify a pure virtual function? Well, we'll say virtual type function name, whatever parameters it takes. And then we say equals 0. That's what we say. So if I want this to be a pure virtual function, I say it equals 0. Notice it has no body. Now, what does this mean? Well, this means that shape has become an abstract class. An abstract class, this is important for a test to remember this, contains pure virtual function or destructor. That's all. Now, what's important about this? Abstract classes cannot be instantiated as objects. Now, if that is confusing to people what I said, that just means we cannot declare an object of an abstract class. So if we look in here, given that knowledge, the compiler will yell at us. Can anyone tell me what line the compiler will yell at us? Because I've made shape a pure abstract class, which means now it cannot be instantiated. And it makes sense because this doesn't have a body. This has no body. So 47 would be okay. Yeah, it is confusing though. I don't blame you. So the reason, notice that this is a pointer to a shape, but we actually don't instantiate an object of shape. So actually Peter gets it here. It would be line 55. We're allowed to, I guess we should clarify that. Let's do that. We can have pointers of abstract class type though. So hopefully that can help. So notice we instantiate a square here and we instantiate a circle here. But the moment we try to instantiate a shape, the compiler will say, hey, no, that's not allowed. And let's see what the compiler says. So we're doing B now. So notice here, it says line 55. It says, because the following virtual functions are pure within shape. And so when it says pure, that means that shape is an abstract class. And the problem kind of spawns here, right? If I was allowed to have this, and then I called print shape details, notice that print shape details has no body, right? So there's no code to execute. So that's all that means. When you see abstract class, it means that we have a class that cannot be instantiated. But we will be using a pointer of it. In a sense, making shape an abstract class is better, because what's the point of instantiating a shape if it, has no details, right? A shape is a square or it is a circle, right? A shape is not an unknown shape, so there's no point to instantiating that. So a pure virtual destructor is the same. Here's where people get messed up, but this is the last thing on this topic. So, a pure virtual destructor must have a body. This is because the base class destructor is always called. The base class destructor is always called. It's a requirement in inheritance. But how do we specify that this is a pure virtual destructor? The prototype needs to be like this. We're going to say virtual class name equals 0. So it's just kind of like up above, but then we need a definition. So let's go ahead and make the shape virtual destructor, a pure virtual destructor. And if you have any questions now, please do, because I'm going to take these last 15 minutes to really talk about the assignment. Ooh, we got a good question here. So we make an abstract class whenever we know for certain that we are only going to inherit from them. Sort of like we would never use a player class in a deathmatch, but a ranger major warrior instead. I would say that's a very good understanding, yes. If you know that a player will never be instantiated in your game, you should make that class abstract. If a player object should not be instantiated, aka allocated or declared, it should be a pure, you should have some pure virtuals in here, whether it's the destructor or the functions, to make sure that we cannot instantiate it. That's a great way to put it. So like I said, this destructor will need a body, so I'm going to put it out here. But since we said it's going to be a virtual, pure virtual, we're going to say this. So this is pure virtual destructor. Sibe asks, what is the point in making it abstract? Just to make your code more general? I would say so. Yes. I would also say that if we were doing, a kid's game, we could introduce probably some game-breaking bugs or some weird things if somewhere in the code we accidentally allocated or instantiated a shape that has no name or no sides. And so, in fact, if we make shape abstract, it kind of adds a level of security to our program, knowing that the compiler will not allow us to do stuff like that. So you don't have to, but if you know that the class has no place being instantiated anywhere, you might as well make it abstract, because then that helps us write better and safer code. So here we got no problem. So here we got the pure virtual destructor, and it needs a body, like I said. Why does it need a body? because the base class destructor will always be called, regardless of anything that you think or try to make the compiler do. The base class destructor is always called. So you always need to have a body for this destructor, even if it is a pure virtual. Here we're basically saying it is a pure virtual, so this class cannot be instantiated, though it will have a destructor. And so I'll just show you that this code compiles, and we should see we don't need this anymore. Because the compiler will yell at us. But I'll show you that the code will run and shape cannot be instantiated. I already proved that shape couldn't be instantiated, but I got a seg fault. What did I do? Oh god. Oh, I deleted S1 twice. Whoops. I deleted S1 twice, guys. And what happened there? I tried to delete already deallocated memory. That's what happened. I would say I dereferenced the null pointer, but I don't think that's what happened. So look, squares 4 sides, but notice that this pure virtual destructor is still called. It's still called. So that's it, really, for virtuals. And so now I'm going to talk about the assignment. If you have questions, go ahead and throw them out there. These notes and the code will go up on Web Campus. The assignment, I promise, is easier than pretty much every other assignment you've done in terms of amount of coding. Okay, you're still going to have to put yourself inside the assignment and find where things go. And the instruction PDF is 8 pages long, but there's really only one page that matters. So if you're on a time crunch, just go to page 8, and not page 8, but go to the page you have to go to and implement it, and then you can be on your way. But I did not want to sacrifice any details. I want you guys to have everything available to you. So that's why it's an 8-page PDF. So I do need to find the PDF. It's probably in my downloads, huh? And I still may make some last-minute adjustments and code comments before I upload it. But look what I give you here. I gave you a description of virtuals. So if you didn't come to class today, you can kind of even read up, in which I tell you to think back to assignment 3, as I gave you that spiel already. I talk about runtime polymorphism here. And then I did this exact same thing in main today, right? So you've already all seen this. And then I tell you how we can achieve runtime polymorphism. In order to do this, we need a base class with a virtual or pure virtual functions. We need derived classes that inherit from these base classes. And the virtual functions need to be overridden. And then lastly, we need a pointer to the base class type. And then I kind of show you here exactly what we did, right? If I make a pointer and I allocate a ranger into it, it will call the ranger deal damage function. So this is just a description of virtuals. You can skip over this part. And then here's the assignment description. Now, some of you may have played RuneScape before or not. I don't blame you if you didn't. But here we made RuNLVscape, which is similar to RuneScape, but it's designed by us. And we're only going to code one small section of RuNLVscape, which is the duel arena. And so in the duel arena, 2 players can battle it out to see who wins. The rules are very simple. Only 2 players are needed, and 1 player is selected to go first. The player who is selected will attempt to deal damage to the other player. Next, the second player will attempt to deal damage to the first player, and then we'll repeat these steps until one person or one player either wins or loses. And I say once the battle is over, both players are returned safely to the lobby of the duel arena. No one is hurt. It's just a game. So players can be one of the following player types. You can either be a DPS, which is a League of Legends term, but this is kind of like an offensive player type. Or they can be a tank, which is a defensive player type. And each player has a special ability. And so this is kind of where the virtual comes in, right? So the damage players have a chance to gain Fury, which increases their attack bonus. And tank players have a chance to negate all damage received to 0. So those are their special abilities. And so these are the functions that will be overridden in the derived classes. And there will be a virtual function in the player class, which is what you'll have to code. And I also say each player has a specific weapon. The damage players use an Abyssal Whip, and the whips have a special ability. And tank players use a Dragon Dagger. And these also have a special ability. Now, I did all that coding for you, but there's also some virtual stuff going on here. So there's plenty of examples for you to see. And so here's the coding file section. And I tell you, you only need to do player HPP, and it's only a small section of it. But here is our hierarchy, where we have entity. Entity is an abstract class. Okay, it's got a pure virtual destructor in there, I think. And then both the player and the weapon inherit from entity. And then we have our tank and DPS inheriting from the player class. And we have our Dragon Dagger and our Abyssal Whip inheriting from the weapon class. So that should make sense. And since we're dealing with virtuals, the player and the weapon are going to be the pointers. And then I literally give you everything here. So you can skip over this. You can skip over this. Though you probably want to look in here because you'll probably want to call this function here and this function. You can skip over this part. And then here you go. Your code here, right? So you can just go from here. And you're actually just going to do this whole class. But it looks pretty much exactly like the other class, except you've got two virtual functions down here. So you'll have to make these functions virtual. And then you're also going to have to deal with this weapon, this weapon pointer. So at this point, I'll probably open the code, but here's just some description, right? I describe everything. And that's it. And once you get here, you're done. So what page is that? That's page 6 and 7. That's all you have to code. And then I tell you about the tank. Notice that the tank is overriding the receive damage function. And the DPS is overriding the inflict damage function. So they're both overriding a different function. And then here's main. Here's compiling your code. And you'll just submit the player.hpp file. So let's come to the code, and I'll just show you what it looks like. All right, so here's entity. Notice that this is the pure virtual destructor. So this is an abstract class, okay? And there's not really stuff going on in here. There's a constructor. I need to add some comments, which I will. Here's a destructor with no body. Here's a get ID. You will call this function multiple times to get the player ID. Every object in the game will have an entity ID. So you'll just call get ID on any object you want to get its ID. And then if we come look in weapon, whoops, nope, that's not what I want. You'll see that the weapon inherits from the entity class. Notice here we've just got some things, and notice that this is a virtual. This is a virtual function. And so notice that this calculate damage just returns 0. But in the derived classes, we override it to do the special attacks. So here's another special attack. So the Dragon Dagger and the Abyssal Whip contain 2 different special attacks. But then if we look in the player class, we will see that we're dealing with a weapon pointer, right? So when we are calling calculate damage from this weapon pointer, we want to make sure that we're calling these functions and not this function. And that's why it's virtual. And so you don't have to do anything in this file either. Super simple. And then if you come to player, you'll see here, I say your code here. So what do you have to do? Literally just come to page 6 and 7 and implement this. Okay? Put all these in here and fill them out. It should not be more than 40 lines of code, maybe pushing that a little bit. But it's just print statements and stuff from assignment 3. Except these 2 things here, you're dealing with the virtuals and the pointer. So you'll put that stuff in there. And then notice down here, I already gave you the tank class. Notice that the tank is overriding receive damage. And in this receive damage, they have a player special. And the DPS class is overriding the inflict damage for their player special. The last thing I'll mention, notice here I'm calling new. Remember that new returns an address. And so when you make this constructor, this is going to pass in an address. You can just assign the weapon pointer to point to this address. But I described that in the assignment. So I'm going to get running this code just to show you how it works. There's still a little bit of a bug. I think that Sally or Bobby is parallelizing my code, in which I try to flip a coin here, and I try to either... Well, let's talk about this. You see here I've got player pointers. These are player pointers. And then in my if statements, I either assign a new DPS to the player pointer or a new tank to the player pointer. And then I do it for the second player. And then I flip a coin to see who goes first. And then we've got a small while loop, which just calls inflict damage, right? Now, if you don't properly make these functions virtual, you will not see any player specials in your code. So that means you did an oopsie there, and you have to go make this function a virtual. But then that's it. At the end, we see who wins, and then we delete the players. So there's some virtual stuff going on in here, right? We have the pointer to the base class, and I'm instantiating different objects into it. So let's run it. Like I said, there's a small bug, but it's not anything bad. Code still works as intended. Woo! All right, let's make this small. That looks a little better. And it's random every time, but the bug that I'm experiencing here, and I was playing around with it, so your output won't be this big, but it's picking both of them to be a tank, and I think that's because it's getting the same random number at the same time, so I'll fix that. But notice that this is just a small output here. Whoops. Let's get a small one. And you can see when the player special happens and the attack special happens. You can see when a player special happens and an attack special happens. And that's it. So this isn't too scary, right? Do you guys have any kind of last minute questions? This assignment will go up today. And I promise you it's easier than Mastermind. You just have to do that one small class. Which is not a small class, but you just have to do that one class. If not, yes. I might give you guys till probably maybe Sunday instead. Saturday, Sunday night. I think that'd be more fair. And then by that time, I can have also the extra credit opportunity open for spring break. But this assignment will not be due next week, just by the weekend. And it definitely should be doable within an hour, if not less, as long as you follow that page on the PDF. So we'll say due date is Saturday night and late due date is Sunday night. And so that's all I got. Ask questions, guys. Thanks for coming to the stream today. I've got office hours in 15 minutes, so please come to that if you would like to talk to me. I hope that you were able to follow this class today. And if not, like I said, just send me a message and I'll help you best I can. So thanks for coming. Happy Monday, everybody. I hope you guys have a great rest of your day. And I will see you guys on Wednesday. You're welcome.